couple of months, I've been learning about distributed applications on the Ethereum network, and I'll present what I'm working on today. I'm calling it Tweet Wallet. The idea is to control your crypto with smart contracts, social media. I have a few premises about why this is something interesting. Firstly, I think, and many crypto enthusiasts would agree, that key management by individuals is essential for decentralized peer-to-peer eCash. The idea that you can be your own bank, that you can have a Swiss bank account in your wallet. It's pretty cool, and to really realize that vision, it's pretty difficult because private key management is really painful. As you may know, if you control Ether or Bitcoin, what that really means is that you control a big long number. And if you lose that big long number, then you've effectively lost your funds, you've lost your money. So that happens a lot, and a lot of people have lost many billions of dollars because of that. So another premise is that tech giants offer the best practicable security, ease of use, and identity management. They offer good services like two-factor authentication, machine-learned fraud detection, and human employees, human judgment. So Twitter may block the person in Romania, picking on Romania, who's trying to log into your Twitter account. They may say, hey, this IP address doesn't match Chicago. Let's alert a fraud alert. So my question is there a middle ground for programmable money where we can have the secure, ultra where we can have the ultra secure security that where we can have the ultra secure network that blockchains offer, and combine that with the ease of use and the good fraud detection and what everybody already uses, which is social media. Can we find a good middle ground? People have tried to do this before, most notably a company called ChangeTip, which facilitated Bitcoin tips. They were around before Ethereum via centralized bots on social media platforms like Reddit, Twitter, etc. If you've been around, you may have heard of ChangeTip. Transactions with ChangeTip weren't on-chain, but they were in ChangeTip's database, and then after some amount of time, you can settle up with ChangeTip and they might pay you out of crypto. So that was good, but it was certainly centralized. We could be better. A potential solution that I'm going to present today is to use smart contracts and Oracle services, where an Oracle service, for those who don't know, is a service that queries the regular old web, a regular website like twitter.com, and inputs that information into a blockchain. And that's a third party, but Oracle's a particular service has reportedly devised a method to do this in a secure manner. So, my potential solution: Ethereum smart contracts rely on Oracleize.it to prove ownership of online accounts. All right, you guys may be wondering what's going on. So this is a web app that I've developed, running on my computer. It's not online yet. But what we can do here, and what you see here, is these Tweet Wallet balances. So we have this demo ETH user 6120. That user doesn't have a balance of any Ether. We have another user, 4343. The user with this Twitter account name has a balance of 0.03 Ether in there. This is running on the testnet, the Ethereum testnet. So if this user can prove that he or she owns this Twitter username via posting something to Twitter, they can come back and claim that money. If we wanted to add somebody, we could do that here. We could say, well, I want to offer some money to Conrad. We could press this button, and I won't do it because it will take a little while, but this will create a new contract on the Ethereum network. And then you can send money to this contract. So it would pop up down here, Conrad with a new address, and you can send money to this long address here, and then Conrad would be able to claim those tips. So let's say we like this ETH user 6120. We'll send this user 1 Ether, and we'll sign this transaction using an in-browser service called MetaMask. This will get broadcast to the Ethereum network, and in short order, we should see a balance of 1 Ether on that contract. So what I've hooked up to here is a third-party service, a third-party website, which queries the testnet Ethereum blockchain. And we see that that transaction went through 1 Ether, and it's still impending. The blocks need to be added, it needs to go through a confirmation process. When it's confirmed, it will update on the web application. This happens to be a Twitter username that I have access to, right here. And if I wanted to claim these funds, which will shortly be in that account, then I need to compose a tweet that follows this precise formula. I need to first paste the Ethereum address of the contract that I'm trying to access. I'm saying, I want the money that's in this address here. Then secondly, paste the address of the Ethereum address that you want the money to be paid out to. So Conrad might have ownership of an account, I might have ownership of an account, and I want the money to go to that account. So let's see if the transaction went through. It did. We should be able to refresh this page and see that the balance of that Ethereum address is now 1 Ether. So this web app is querying data, again, from the Ropsten blockchain. And incidentally, this is the address of the parent contract. For the techies out there, this follows the factory pattern, and so a new contract is created every time we create another tweet. We offer another potential reward. Good. The transfer went through, and now if this address is this balance of Ether, 1 Ether, let's confirm that there actually is 1 Ether on that address, on that website, Etherscan. Indeed, there is 1 Ether, 1 Ether in that contract. So, I am ETH user 6120. I have some tips, I have some payments. Maybe I've sent money to this contract myself because I don't trust myself to be able to manage my own private keys. For whatever reason, I want to claim the money's in there, and now I want to get it. And so we have this address here, ending in 69D. Here's the address ending in 69D. And we see that it currently has about 1 Ether. We haven't claimed it yet. When we claim these funds, what should happen, knock on wood, is that that will go to 2 Ether. So with Twitter, every tweet has a unique status. And so we're going to copy this status right here. And we're going to submit a claim to the Ethereum network. Everything looks right, I think. This is my Twitter username, this is the address of the contract, and I submit this claim to the Ethereum network. Let's give it a lot of gas to make sure this goes through. So now this is doing a lot of work, actually. What's going on now is that we took that status ID, this status ID, and we sent it to the Ethereum smart contract. The Ethereum smart contract is taking this information and concatenating it all together in one long URL that has the Twitter username of my Twitter username or whoever's claiming the money. Then what's going to happen is Oraclize, we're going to send it Oraclize, which is a third-party service that's doing, that's getting money, that's getting data from outside the blockchain and inputting into the blockchain. Oraclize is, for a fee, going to query that Twitter URL and get the data that I've tweeted out here. So it's going to get this data and return it to the smart contract. The smart contract is then going to parse this information and make sure that this matches up, make sure that this is a valid address, and then send the money to this address. So if all goes right, by now or shortly, we should see this balance go to 0 because it's now been claimed, it's now been paid out. And then we should see this account go to around 0. Good. So we got our money, we claimed it successfully, and when this data returns, this should populate with around 0. We may need to refresh one more time. It looks like it took some keys. So I'm not sure why people would want to use this. I mean, but it's been pretty educational. And thankfully, that did work. So we have a balance of 0 ether there. So that's the demo. Just some few remarks in conclusion, and I can either take questions or we can move on. Some challenges of privacy. Maybe people don't want to share how much money they're getting or whatever. Another challenge is that Oraclize is a trusted third party. The use of oracles remains just the big question in crypto. How do we take information from outside of the blockchain, input it into the blockchain in a trust minimized fashion? Social media accounts are often trusted third parties. But instead of just using your one Twitter account, what if we could do something where, hey, I'm going to spend some money, and it's a big purchase. Maybe we could do something like, well, I need authorization from Twitter, I need authorization from my Google+, I need authorization from my Facebook, or whatever else people use. It can be any URL, any website that you have ownership over. And for a small transaction, you might only require one of those approvals. For a large transaction, you might require more. Another challenge is that SSL TLS or TLS notary proofs, which are the cryptographic proof that Oraclize purportedly uses to get information from outside the outside world and input it into the blockchain in a trust minimized fashion. TLS notary proofs, very, very difficult to understand. You have to be a cryptographic expert to understand what's going on. That's a difficulty. Finally, basic technical implementation challenges in smart contract development is significant. And there's a lot of stuff that could have gone wrong in that demo that I'm thankful did not. So here are some of the tools that I used while developing, mainly the Truffle framework, which helps you combine the front end, which you saw on the screen there, with the Ethereum network. Oraclize is the Oracle service, a development environment that Oracle offers, Go Ethereum client, MetaMask, which is that thing that showed up with the pop-up that you can sign transactions with, and Etherscan for third-party verification of transactions. So a quick recap, the basic idea is a vision where the probabilistic solutions to private key management using oracles and already used sources of online identity can offer a compromise between ultra-secure blockchains and ease of use for the average person. So this code is open source. You can find it on GitHub. There. You can find me here and on Twitter. And thank you very much.
By the way, is Nicole Villa here yet? Okay, so I guess we have time.